Okay, so you've got yourself one of these SmartCar chassis and you want to get it hooked up to something a little bit more useful, like a Teensy with a PRT motherboard and maybe a motor driver. And what you're going to need, you can do it any one of a number of ways, but I have designed a little template here that fits very nicely on the chassis that'll give you lots of places to attach things and make it portable and easy to move around. There's lots of different types of chassis like this. I do have this set up so it does in fact line up with a couple of holes down below, so you can screw it down if you want through the bottom and help secure it. But actually it rides on here pretty nice, so that may not be actually necessary for some simple experiments. And I've also put lots and lots of different holes in it, so you can put, the motherboard in any one of a number of different locations. I'm actually probably going to put it off to the side, make it easy to get the USB cable and not interfere with the wheels or anything like that. And the same with the motor driver. It can go a number of different places. It can go here or it can go there. And it's also pre-drilled for a different kind. This one here, this L298, it can go here or here, of course flipped around. And the only other things you're going to need are some screws to put it all together and some jumper wires to hook it up. So I'm going to go ahead and get this guy going, and we're going to keep it really fast and really simple. And get the basic operation going and test the wheels, and we'll call it done with that. I will say these holes are not tapped. They are laser cut at 2.2 millimeters. So to get them in, all you have to do is kind of apply some firm pressure and they'll screw right in, okay, using a 440 screw. And I'm actually just going to really loosely put this on right now. I'm not going to use spacers, I'm not going to do anything fancy, and I'll just use a couple of screws so we get done quickly here. It is worth noting that since I'm not using spacers, you're going to want to not tighten the screw down. It'll cause the board to, cantilever up on the solder joints. So what you want to do is you want to uniformly tighten each one at a time until it gets down there kind of firm and smooth. If not, it'll be standing up on end because of all the solder joints. And I think I'll put this guy maybe here. And again, I'm not going to spend a lot of time on this. I think I'll just put a couple of screws in to get us started. I'm using 1/4 inch 440s. Alright, excellent. And the next thing we have to do is attach the motors, and you'll see on this board, if you look at it carefully, and maybe I'll zoom in on it here if we can, we've got an A, a B, oh come on focus, a ground and a VN, okay? There's also a VCC and a ground on this side. I'm not going to use this VCC. I am, however, going to tie this ground to my motherboard. I like to have all my grounds tied together as much as possible. But I am going to go ahead and use this voltage in and this ground and tie it to the motherboard. So let me get this guy down here. And I'm simply going to put this motor into position A, like so, and tighten it down. Like so. I'll loosen this one up again, and I'm going to put B, and I have no idea which one should be where. We're going to figure that out with code. I'm just sticking them in there, and we'll deal with the outcome later. So I'm going to use this male-female wire pair here to hook this up, and I'm going to choose the brown for ground. And I'm going to use the red for the positive. I can loosen this up a little bit. Okay, and since the PRT motherboard has a separate switch for this side here, I can actually power this side of the board with this switch. Pay attention here. I'm actually running it, the jumper. I have it set on VN. Okay, this jumper's over on the VN side. That's going to allow me to run this thing at 7.2 volts when it's plugged into the power supply, since I'm using 6 rechargeable AA batteries. This jumper is set at excuse me, at 5 volts. And this one, of course, is on ground, not analog ground. I would leave it there. So I'm just going to plug this guy into, for example, it doesn't really matter, any of the outer pins and any of the middle pins. Since all the pins in the middle are power and all the outer pins are ground, and the ones closest to the chip are I/O. Alright, and now we'll take this guy, and like I said, I'm going to use this ground. I'm going to take advantage of that ground, and I'm going to choose 4. I'm just going to put it in sequence like so. And I do want to mention we have a couple of options here. At the moment, I have 2 jumpers on the enables. Okay, so that's going to lock them into 5 volts. They're going to always be on. I'll show you by the end of this video, I hope, if not another one, how we can remove these jumpers and take advantage of the PWM pin on the Teensy to vary its speed. But for the moment, I just want on and off, left, right, forward, and back. So I have 2 jumpers set in this position. And I do actually want to pull up that website with the pin IDs, and let me pause it and I'll find that real quick. I'll be right back. Okay, so like I said, I do want to be aware of the pulse width, the PWM pins, should I decide to use variable speed using the PWM controller. So there's several of them on the Teensy 3.1 and 3.2. You can see here that pins 3 through 6 are all PWM pins, as well as 9 and 10. I think what I'm going to do, just to keep it clean, is I'm going to use pins 9, 10, 11, and 12 to control the 2 motors, A and B. And then if I want to, at a later time, I'll take 5 and 6 or 4 and 5 or something up here to do the PWM. So let me get this out of the way. And like I said, I think I'm going to take these wires here and I'm going to wire them up just straight in a row. So keep it really simple. I'm going to put these in 9, 10, 11, and 12. And I suppose I should have done this while paused. There we go. And then, like I said, I'm going to take this last wire and make sure that it's grounded on both sides of this board. So I have a ground on this side and a ground on this side, but I am leaving this VCC, this positive one, unused. So let me go ahead and pull up a little piece of code and write something. Let me pause it and I'll get that set up. Okay, so I've got myself a new sketch. I'm going to keep this really fast and clean. The first thing I need to do is set all the oops, see if I can do this without. I need to set the pins to output modes so that I can control the motor. And like I said, I'm using 9, 10, 11, and 12. And let's just do a simple little experiment here. Let's do a let's make a forward function, and oops, well, I got an extra parentheses in there. Sorry about that. So to do that, remember that these motor drivers need to have there's 2 wires that go into the microprocessor for each motor. Okay. So for A, I have 2 pins that go into it, and if I have one pin set high and the other one set low, the motor is going to spin one direction. And if I flip that to the other side, so that, I'll go use these 2 fingers, so one is high, one is low, it's going to go one direction. If I flip it, it's going to go the other direction. And if I get both of them low or both of them high, it's going to come to a stop. Okay? So what we need to do is come up with some kind of a scheme, and I actually have a little piece of code over here, and I'm just going to copy and paste. So now, I'm going to just do the experiment. I'm going to go ahead and see if this makes it go forward and which wheel, because I really don't know yet. So let me pause it, hook it up, and load it for the first time, because it takes a minute, and I'll be right back. Okay, so I corrected a little typo there I left you with, and called the function, and I've uploaded it, and lo and behold, if I turn on the power, we can see that the left wheel is rapidly moving forward. It's perfect. So I'm going to shut that off, and let me create the left wheel, which is going to be nothing more than copying and pasting this. And we'll make this 11 and 12. And we'll load that up and see if we get lucky with that one and if it goes the right direction. Ah, shoot. Okay, so this one needs to be flipped. So let's just do that. Let's make this high and make that low. And we should now have a forward. Yep. Okay, awesome. So let me do a couple other things and I'll be right back. Okay, so I've added a delay into each. I actually created another function, stopBot, where I set everything low, as you can see. And I've added an argument, okay, which I call delay, which is going to be how long I want it to run. Because remember, these motor drivers stay on until you tell it to do something else, okay? And in this particular case in the loop, I have it going forward for a second or 1,000 milliseconds and then stopping for 5 seconds. So if I turn it on, you can see that it will take off and run for a second and stop. Okay? So let me add another function to this and I'll be right back. Okay, so I've added several little functions here. What I did is I essentially copy and pasted the forward a few more times. And I changed the directions appropriately, so I have a reverse, of course, which is the exact opposite of forward, and just by flipping the highs and lows. The left and the right, the turn left and to right, I have just carefully made sure that I chose the right wheel and flipped one of them so it does the turn. And I've created a little function here, or a sketch, that is going to demonstrate all of them in motion. And we can test it right now. So let's get it going. Alright. And you can see that I have all the necessary drive functions. So I'm going to do one more thing, and I'll see you guys in just a few. Okay, so what I've done is a couple things here. You'll note that I've pulled the jumpers from the enable pins here. I have ran 2 wires, in this case over to pins 5 and 6, which we discussed earlier as being PWM pins, pulse width modulation pins, which I can pulse at a very precise rate with easy coding. And that pulsing is going to allow me to change the speed of the motors. So what I've done in code, of course, is I've added those 2 pins as outputs. And down here, I just played with only the forward. I've added 2 more arguments to my function, and those arguments are going to take those pulses that I send to the motors and analog write them. So if I call a value up to 255 into either analog write pin 6 or analog pin 5, that is going to pulse that enable pin on and off, and that is going to then change the speed. I called it up here. I just did a simple little loop with my forward. I played around a little bit. My motors don't really go below 80. That anything less than that, it starts to stall out. So my minimum speed is going to be 80. And I just stepped it up in a sort of an incremental way. And I've already uploaded it. So if I turn this on, you'll be able to hear that it's very clearly going through a series of speeds, each one set by these values in the argument, going down here to the function, and then of course being used in analog write to pulse the motors. So hopefully that's a pretty good start and setup for you, and I'll add some more functionality soon, and I will see you again soon.